University of Tokyo, and welcome back to our very final session for this seminar series. Let me share my screen. So this is today's schedule, and because today is the very last session for our entire seminar series for the last few months, we would like to have the reflection or the overall discussion at the very end of today's session from 7:30 to 8 Japan time, or 11:30 to 12 Central European time. And if you have to go, you're not required to stay, but you are welcome to stay. And it would be great if you can share your thoughts on the seminar series and what you thought about this seminar. But before that, we have a session on AI, body, and aesthetics. And I will briefly introduce what this seminar is about, or at least what I conceive of this issue or the question of AI, body, and aesthetics. And then we have three wonderful presenters from the University of Tokyo mainly, and then discussion or Q&A session at the end. And if you have any questions during their talk, please, you're welcome to post your questions or comments in the chat, or you're welcome to speak up at the end of the session. So first, I want to introduce just briefly about what I mean by aesthetics here, which is, I think, quite important. So here, aesthetics means not simply or not merely about the outer look of things or something beautiful, but it's about lived or felt experience, knowledge obtained through the senses. So it's a sensation or perception of people. So to study or to understand aesthetics is to understand people's or our perception of and also relationship with their surrounding environments and also people. So it's understanding the relations and perceptions between people and also people and environments, or people and object or materials as well. And this kind of understanding of aesthetics or aesthetic experience is contingent on political, social, and cultural context, and it's not really uniform. We have different kinds of aesthetic experience depending on time, place, and the social conditions. And I think thinking about aesthetics allows us to think about beyond the body-mind dualism and also the subject-object dualism, because I'm not going to go into too much detail about the discussion about aesthetics, but the discussion about aesthetics is to think about how the subject-object kind of merge together, and also how the body and mind, or the sensation and this understanding of the sensations are closely interconnected, and how these ideas about aesthetics can help us understand AI or AI-human relations is that I think this kind of aesthetic approach allows us to look at AI not as an object, or not objectifying AI as a machine or material object, but maybe we could look at human AI relations, hopefully from a new kind of fresh perspective, or in a more dialectical relations. But I think looking at human AI relations as a kind of influx or dialectical relations generates or pose a challenge or problem, in particular about relational accountability, which I mean by kind of the difficulty of pointing out who has ethical responsibility. So because if AI and people, or for example, the AI developers, their relations are located in a kind of network or in a very dynamic relations, it is quite difficult to pinpoint where the responsibility is located, or it is not even possible maybe to locate where the ethical responsibility is. So I think this approach has a potential, I think, but it could generate a new kind of question or challenge as well. And today's three speakers kind of look at directly and indirectly, I think, points to this ideas about human AI relations and influence of AI on human perceptions, sensations, and also the relations between human body and AI from different perspectives. So I look forward to their talks and also our discussions at the end. So, okay. Okay, then let's move on to Alyssa. Yeah. Okay, so hi, Alyssa. So Alyssa is currently research collaborator at BAI Global Forum at the University of Tokyo and also a former graduate student at the University of Tokyo. And she just graduated from the master's program at the university this past October in 2024. And she's interested in how technological innovation and deployment impacts regions like Southeast Asia and East Asia, and has worked on multiple projects concerning gender, disability, business innovation, and AI. And I've been seeing her project, including her master's thesis and some other graduate projects, and she's been working on very, very interesting projects. So I look forward to your presentation today as well. So, hi. Okay, so Alyssa.
Thank you very much, Professor Hisano, for a really kind introduction. I guess I don't need to introduce myself. So today's presentation, I'd like to explore what I talked about in my master's thesis in relation to generative AI and what it means what generative AI can do to affect desirable images of a healthy human. So in today's presentation, I just want to start off by saying that my master's thesis was largely inspired by works of Sarah Ahmed and a lot of other social materialist affect and actor network theorists. So I'll be taking a standpoint in that intersection of technology, culture, and ethics in relation to my master's research. And also, I will consider AI as an assistive technology designed by humans for humans, so that it is also vulnerable, meaning that it's also vulnerable to the same biases that end up oppressing certain bodies within certain social structures or assemblages. And at the end of my presentation, I also want to briefly segue and introduce a project run by alumni of the BAI Global Forum called Perception. So I'd like to take a few minutes for that. So to begin with today's presentation, I just wanted to give a little story about why I'm so interested about desirable bodies and the meaning of desirable bodies in relation to AI. So one personal motivation to this, exploring what bodies are from a medical perspective, is from working with people who had to fight to justify their experience bodily, cognitively, and existentially. So volunteering in Ho Chi Minh City in 2014 for a couple of years, I saw children who actually were in orphanages that whose missions were to alleviate the plight of those children affected by the Agent Orange from the American War in Vietnam. So this really highlights, I think, the gravity that diversity and inclusion initiatives today, especially ones that promise innovation and are often used by big tech companies and AI developers, what those really hold and what the stakes are for people who will be affected by images produced by those kinds of technologies in the future. So for my just a little more context, I'd like to continue this research in the future, so I won't be going into too much detail about what the contents are, but what I really want to emphasize is the framing of bodies. And for example, although our search engine today post technological outputs, so if we search up anything on Google, for example, we often find that they're quite related to one another, and we've gone so many years used to it, and the output is often seen as scientific and objective. So it's good to reflect on it as something more like subjective craftwork. So for my master's thesis, what I wanted to explain is the way that human culture molds the body. So in my master's thesis, I sought to challenge the disenfranchisement of differently abled bodies using affective theory, and a lot of research has already been done to create a methodology to explore and in a very with a taxonomy and methodology to explore different ways that design is done in a human-centered way, and ways that we can point to certain humans or non-humans within a network and how they affect each other in those kinds of important decisions towards new changes or innovations. And that's included within business practices from ideation phase, design, testing to the output. So one of the things that I think can be considered within AI, although my master's research was about prosthetics innovation and how different human and non-human actors, including the prosthetic device itself and the doctors and the practitioners, how they affect one another. I think this also applies to AI technologies and AI models today. So just a few more examples. Reading the literature in English, French, Korean, and Japanese on prosthetics, and doing some fieldwork in Japan and Korea and Vietnam, I saw that there was clearly an orientation towards Western-centric models of so-called healthy human body, and that's reliant on a lot of neoliberal business and healthcare practices. So one of the things that I wanted to suggest was to bridge those goals that are almost inherent in any form of innovation, the business goals, the academic and innovative goals, to build a map of the actors that are have the capacity to affect one another, and make it really clear and justifiable why one innovation is preferable or desired over another, and what decisions and actors may be pushed aside, or feelings or emotions or affects are pushed aside in favor for one innovation decision over another. And of course, innovations can go beyond just updated technologies of visual aesthetics or haptic feel for prosthetics, but also any decision for innovation contributes to an innovation of knowledge about the wider affective network of bodies that define what is desirable or not. So overall, my kind of relationship of the master's research to the study of prosthetics innovation in an affective sense to AI is because it reflects on the meaning of bodies in the presence of technology. So, for example, when we're reflecting on bodies, how do we navigate the knowledge and the experience around bodies and of bodies when AI is so ubiquitous? So, for example, for specifically, I'm interested in looking at this inquiry for children in the future who will be using AI. So not necessarily prosthetics, but AI. So what kind of affective relations are prioritized in the stories that are relayed to children to use these designs, these innovations? And how do we make it apparent or visible or tangible or felt? What characteristics are desired within a certain technology, how it came about. And so I believe that looking at an affective framework through the work of social materialist theories, actor network theorists, and affect theorists can give a lot of insight into technological innovations today. And so as a segue, I'd like to bring us to thinking about the internet, which is a huge effective technology that impacts human bodies, whether we like it or not. So this is a clip of a site on the screen, and it's a project called Models All the Way Down by Knowing Machines. And it uncovers how search engines for images, and now those that AI operate on, are traceable to the manually inputted tags that are often written by retail sites or influencers who find those profitable keywords that might get the most clicks. But that is essentially what AI models are built on. For example, ChatGPT, Claude, and other chatbots that use LLMs or other visual or textual or sensorial databases. And those are built on what is the highly interconnected and socially engineered, entangled internet. So just for today's session, because we're talking about a desirable body, and I'm sure for everyone who's joined today's session, you probably use the internet through a browser with a search engine, and in that sense, you've probably done or have tried yourself something like searching for images. So for example, if we're looking for images for a presentation for work or for a presentation like this, we more often than not look to the internet for free or usable images. And what comes up are images with long tags or multiple tags usually, and those that match your query will come up. But on these more recent stock photo websites, there are AI integrations, and the little widgets like this allow you to optimize your output. And or one other process that you could do is to modify the existing images. So if one of these images don't really fit your understanding of a healthy person, then you could edit it with AI. But it raises the question of why or how that output can come about. So from another standpoint, we can look at it through the works of anthropologist and feminist STS scholar Lucy Suchman in 1993, as early as then, saying that AI is a complicated craftwork, subjective craftwork. And according to them, AI involves the work of people representing, or these days masking, human behavior, representing human behavior as the skilled, socially and materially organized practice of AI. And this is also related to another scholar's point of view, where AI, just like other technologies, consists of a family of methods for associating and channeling other forces, non-human and human forces, to heterogeneously engineer a constructed system towards creating a stable system of emergent properties. So I think when we're using a lot of the things that we're using today, it's really good to think of AI as a craft work and a result of AI researchers bringing the practical activity of whatever it's promising to assist us with under the jurisdiction of these runnable programs. So a final thing as well is that once you look in such a simple thing as a search query and try it out in a different language, it's really surprising that it already produces a very different array of visual outcomes. And I'm sure that the developers have done the same kind of algorithm to help show what may be most desirable, no matter what your query is. But you can see that even with a simple switch of language to Vietnamese or Filipino, the visual outcomes from a similar phrase produce very different visual array. So it will be quite important to think of it affectively again about how the suggested desirable bodies is in the context of using AI in the age of AI. So is there a question that we can also ask is whether there's a way that we can transform these network systems online, on the internet, or of AI models into a more understandable assembly of affected actors, of the human and the non-human, and what the relationships between them, how they manifest. And the idea of desirable as well is what underlies which humans and non-human actors within that affective network is prioritized over others. There are already many efforts being done by researchers, developers, and big tech companies to safeguard AI from perpetuating unintended biases, especially across different languages or different cultures. But there are still so many contradictions in the ways that these groups bridge the interests of their different institutions and goals for profit. It costs to improve those technologies. It costs to prevent it from producing undesirable outcomes, and it costs and requires further convincing between people to justify those preventions. So understanding it within an affective network, and especially understanding it within a capitalist affective network, will be really interesting. And whether or not it will improve towards certain innovations will be something else to explore in the future. So I can drop a few discussion questions for food for thought, but I also wanted to briefly kind of show ongoing project by the graduate student alumna of the BAI Global Forum called AI Perceptions. And the current website, when you go to it, is still not this state. But if you are interested in looking at more explorations about AI in terms of affect or alternative radical bodies, materiality behind AI, we look forward to you viewing it and any discussions or comments that might come from it. Thank you.
Thank you very much. Thank you, Alyssa. I'm very much interested in your idea of affective AI, which I think generates or poses many interesting questions about AI, and also in relation to the human body as well. So thank you. Now, do we have any kind of clarification questions from the audience? Okay, if not, we will move on to the third speaker, Professor Grant Jun Otsuki, a colleague of mine at the University of Tokyo. Dr. Grant Jun Otsuki is an associate professor in cultural anthropology at the Graduate School of Arts and Sciences at the University of Tokyo. And he specializes in the anthropology of science and technology and also culture, and also SDS, science and technology studies. And before joining the University of Tokyo, Professor Otsuki had taught at the cultural anthropology program at the Victoria University of Wellington, New Zealand, and also at the University of Tsukuba in Japan, after receiving his PhD in social cultural anthropology from the University of Toronto. And he has numerous publications, one of which I found quite interesting was about toilet papers, not necessarily about AI, but it was quite interesting paper. So Grant, the floor is yours.
Great, thank you for that introduction. I'm very happy to be here and to be able to talk to this audience, but also to hear the other presentations. And I think there are a lot of interesting connections between them. I'm going to talk about, well, my talk is titled Towards a Post-Turing Typology of Human Technology Relationships. And I'm going to somewhat immodestly claim a few big arguments as hopefully as provocation for the discussion that follows, but hopefully they also spur some discussion about the connections between the three talks that we've had today. I want to start by briefly mentioning a recent short film from the Netherlands called I'm Not a Robot, directed by Victoria Warmerdam. The film, which you can watch on YouTube, is about a woman who fails a series of CAPTCHA tests. So these are the tests that you run into when you're trying to log into like a bank account. But CAPTCHA stands for Completely Automated Public Turing Test to Tell Humans and Computers Apart. And she fails these tests and begins to question whether she is a human or a robot. So the audience watching her confusion is similarly confused. She looks and she acts human. How could she not be human? But if she's not, then are the other characters justified in treating her differently or limiting her freedom? Or, when she offers to help someone in the film, is she doing it because she's kind or because she's been programmed to serve? So I think this film captures in part some of the discussions I want to have today about what happens when we become unable to tell humans and machines apart. Now, so when we recognize another being as human, we entitle it to be treated quite differently than just a machine, even though recognition is rarely enough. So human history is full of instances of violence and tragedy that have been made easier by denying or rejecting or ignoring people's humanity. And ironically, some non-humans, like pets, can be showered with care and comforts, even though they're unambiguously not human in many eyes. But still, at the very least, to recognize another being as human constitutes an assertion of a belief in its species membership, its material composition, its cognitive and ethical capacities, and its social proximity. Well, consequently, that recognition establishes norms about how we should interact with it, how to communicate, how to cooperate, how to treat it with dignity, even if in reality we fail or refuse to meet up to these norms. So each of us then has a body of knowledge and habit that's accumulated over our lives. That means we know virtually intuitively if another being is a human or if it's, say, a machine, and how we should then behave towards it. But what if we had trouble telling the difference? It would mean that the ways we treat other people would begin to blur into how we treat certain machines and vice versa. And one of the problems is that we don't think about or treat machines very well. So the argument I want to make today is that when it becomes difficult to tell the difference between a human and machine, then we need to begin to think differently about both. And this is a situation that I want to sort of immodestly call the post-Turing condition. Now, I want to show that when we talk about technology, we tend to think about it as a slave, and that this has roots in the history of computer science and information theory. But then I'll turn to a sort of connected but somewhat parallel history of information in Japan to discuss how thinking about information differently connects to thinking about machines as things that are other than slaves. The talk today is going to sort of take us to the cusp of these other ways of relating with machines, and I can talk a little bit about this more during the discussion time if there's interest. But I want to start with the Turing test. So the Turing test has become a culturally iconic way to tell the difference between human and machine. It was proposed by a famous mathematician, sort of pioneering computer science named Alan Turing, modeled after sort of a kids game, parlor game called The Imitation Game, which is also the title of a movie that was about him that came out a few years ago. So he came up with this test to answer the question, can a machine think like a human? And he said that the testable way to do this is to see in a text conversation whether a machine communicating with a human being could trick that human being into thinking that it was the human when there's a human on the other side. So the test is set up so that the judge can't see who they're communicating with. They only communicate through text, through screens or teletype. And it's through these text conversations that the judge needs to decide which of their partners is human and which isn't. And if the computer is able to deceive the judge into believing that it's the human, then Turing believed that this would provide a strong reason to conclude that the computer could think like a human. Now, since then, the test became sort of a de facto benchmark for gauging the development of human-like artificial intelligence, and a touchstone for endless debates among scientists, engineers, and the public about how and when machines that think and act like human beings might become possible. If you follow somebody like Sam Altman, who's one of the founders of OpenAI on Twitter, and you'll see him post things like, we passed the Turing test, but nobody noticed, right? So it's this sort of symbolic landmark of human-like artificial intelligence. Now, even though Altman and many others took the Turing test to be something like an objective method of determining a machine's humanness, in its very composition, the Turing test makes extremely strong assumptions about what characterizes humanness in the first place. So the first thing is that by relying on text or teletyped communication, it takes for granted that what makes us human is the ability to interact as individuals through disembodied language. And Turing, in the paper where he talks about the Turing test, discounts the body as important to thought and calls actually the body a disability. And so the job of the human, the judge C in this situation, is to judge which of the conversation partners is most adeptly managing, manipulating language, using language most persuasively, with the implication that if it can do this, then it would be essentially human. And moreover, by isolating each participant in the test as an individual from the others, the test assumes that humans are essentially autonomous and that human-like machines must also be able to act autonomously. So on this basis, the test implies that humans and machines are, in principle, equivalent and exchangeable. Each is neatly packaged as an autonomous individual, and it's linked with others by narrow forms of communication. And so the Turing test imagines human relationships in terms that allow for their easy replacement with linguistically adept technologies. This is all accompanied by the dematerialization of the human and machine bodies. So this shows is that what's essential to humanness in this view can't reside in the material body. And what makes a human human is how they use language, or in other words, how they process information. Now, the idea is a rearticulation of a very classical Cartesian mind-body dualism, but it's a dualism that was shaped in powerful ways by its mid-20th century American context, or I should say the North Atlantic context, which took the mind to be the master of the body, which was its slave. Now, the idea that machines should be slaves is pervasive in representations of autonomous machines that were developed in the 20th century United States. And even today, you'll see the metaphor of master and slave used often in engineering, where it's used to describe the relationship between two systems in which one controls the other. So the master system is considered the brains, and the slave is the brawn. Now, an STS scholar, a historian named Ron Eglash, he points out that the language used for master-slave systems echoes pre-Civil War discourse on slaves. And he allows that this may not have been an intentional reference to human slavery, but another scholar, Louis Soke, argues that from within that historical social context of 20th century America, that autonomous systems could hardly have been taken to be otherwise. They could be. It was hard to think otherwise about machines in a context where the problem of humanity was so often tied up with the question of the humanity of Black slaves. And so Shud Soke argues that in the US, these technologies were, quote, explicitly considered in terms of American racial politics, in terms of mastery and slavery. Now, one of Turing's contemporaries was attuned to these meanings. His name is Norbert Wiener. He was an MIT mathematician, and he, alongside other people like Claude Shannon, developed key ideas in information theory and cybernetics. And one of his contributions was the argument that biological systems and automated machines are, in essence, both information processing systems. So, like Turing, what a being is made of materially is not really important compared to the way that it processes information, making human and machine, in principle, possible to be made equivalent. But Wiener, what he does is he goes on to think about what are the social and economic consequences of machines becoming human enough in this way to be able to replace them. Now, in a best-selling book that was released first in 1950, he takes up this question and he warns that the automatic machine, quote, whatever we think of any feelings it may have or may not have, is the precise economic equivalent of slave labor. So what he's saying is that if we have such capable machines in this way, that humans made to compete with them would also become like slaves. He says, quote, atoms knit into an organization in which they are used not in their full right as responsible human beings, but as cogs, levers, and rods. So the more human in this view that a machine becomes, the more machinic the human can be made. So he translates the problem of distinguishing human and machine into the task of maintaining humans' mastery over technology. So that's maintaining the effective enslavement of machines in service of human needs. And this is expressed by a computer scientist of the following generation at MIT named Marvin Minsky, who put it this way. He said, smart machines are inherently trustworthy. And he says, quote, there's the old paradox of having a very smart slave. If you keep the slave from learning too much, you're limiting its usefulness. But if you help it become smarter than you are, then you may not be able to trust it not to make better plans for itself than it does for you. And so the impulse is to exercise more total control of the slave. And I think that a lot of contemporary fears about smart technologies overthrowing humanity that are espoused by philosophers and scientists and technologists are rooted in this view that the machine is a slave and that it might become a slave so powerful that it will one day overthrow its master. Now, I'm going to shift here to talking about Japan, because cybernetics comes to Japan very early on in the very late 40s, 48, 49 into 50, and it gets a lot of attention from many different people. But among the first to take up this cybernetics and think through it was a group that called themselves Logergist, and they're actually based at the University of Tokyo around 1951. So they were a group of mathematicians, physicists, and engineers that started meeting regularly as the cybernetics study group because they were interested in Wiener's ideas. But they also went on to discuss a lot of other philosophical and scientific topics, and they ended up publishing a series of 10 books under this collective author name, Logergist. So they were really drawn to cybernetics by the idea that it could help it unified sort of the study and understanding of physical and organic worlds with problems of control and communication that they were familiar in engineering. But their name was also a critique of cybernetics in Wiener's version. So Wiener came up with cybernetics as kind of a new way to talk about his science of information, of control and communication that he took from a Greek word that meant governor. So Logergist decides to do the same thing. They say, it's very interesting what Wiener has done, but he's missing a large piece of the puzzle, which is energy. They were very concerned and they criticized Wiener for leaving out the energetic form needed to transmit information out of his discussions of information. So they called this katachi, the energetic form that information takes. So, for example, might, in principle, give the same information through sound or through electrical impulses, but the kinds of senses you need, the kinds of energy levels you're dealing with, and the forms of energy to produce those, to transmit that information is going to be quite different, and that will have implications for how that information is received and interpreted. So to mark this difference from cybernetics, they came up with this new term combining the Greek words logos, words, and ergon for work to come up with logergic, which is how they talked about the combination of information and energy. And so marking their difference from Wiener, they thought about information as what's communicated, what's exchanged through interaction as this combination of information and energy. Now, Wiener thought about this question at times, but he tended to discount the importance of energy where it came up for him. So he would talk about, like, the brain is a computer that works on a very few, milliwatts or watts, and it's doing something more amazing than a computer that takes up an entire room and may use kilowatts. And so he concludes that it's not the watts, it's not the form that matters, it's the pattern of information. So brain, computer, more or less the same thing. But Logergist did not do this. Where information could be separated from what I'm going to sort of move on to a discussion of the bodies that produce it, the bodies that sense it, whereas for Wiener, they could be dissociated. But this led descendants of Logergist, and so I'm going to skip ahead about 40 years, to take the kinds of problems that Turing had about thinking about what human beings are, how they think, and whether machines can, and to kind of invert his problem. So if Turing knew that disembodied language captured humanness and that machines needed to be able to use language, the people that came after Logergist in Japan took humanness rather as a puzzle that they used machines to try and unravel. So to illustrate, sorry?
3 more minutes.
3 more minutes. Okay, thank you. Okay, perfect. So these descendants of Logergist, so there's a genealogy that links Logergist to a lab where I did field research a few years ago. But this lab had their own version of the Turing test called the embodied Turing test or nonverbal Turing test. So like the classical Turing test, it links human and machine through jive. But rather than through interacting through text, their interactions were through touch. The human participants each had sort of a vibrating coil on their fingers, and they could virtually touch each other or a machine through their fingertips. And none of the participants were aware of each other. They could only interact through that sort of limited touch. Now, when I speak to the researchers, what they say is that the touch was chosen because, quote, there is no need for humanness to reside in interactions mediated by language. So rather than assume that the essence of humanness was existing solely or primarily in a symbolic or linguistically mediated conversation, their version of the Turing test took bodily inputs and outputs, so these touch interactions, as a possible way for humanness to be communicated. And one of the researchers went a bit further and saying that even spoken language is at root a set of muscle movements. So in that lab, what defines a human before it can speak or type is how its body moves in and through the world. And in their version of the Turing test, it turns out that people are pretty good at distinguishing human from machine just through touch. And there are a number of ways that happen, but it has a lot to do with rhythm and duration of fingertips and turn taking and all of this. But they could also tell this, apart from a machine, a non-human. So even though sort of in broad strokes, this looks like something very similar to the Turing test, I want to note one major difference, which is where the Turing test, the classical version of the Turing test, assumes that symbols, that language, that disembodied information are the means to communicate human thinking, that the embodied Turing test takes touch as a possible means of communicating humanness and uses it to test how well the sense of human can come through that. So what it does is that it turns this conceptual relationship between human and technology sort of inside out, right? The experimental context of linguistic transfer in the classical Turing test is sort of unfolded in a way that makes the human the context of experimentation and gauges the effectiveness of touch, of bodily interaction to be that way of, to see if it's a good way of communicating humanness. I'm going to stop here, but throughout the rest of my research, I encountered many other ways to attempt to explore other kinds of human technology relationships that took humans not necessarily to be slaves or servants, but for instance, as babies or children or parasites or partners in symbiosis, as pets and companions, or as embodiments and bridges to even the supernatural. And so the unfolded context of the human, these sort of relational models become motifs for guiding their experiments that go beyond the aim of making technologies that are easier, more convenient, that is more than good slaves, but might open into other kinds of relationships that do not presuppose the enslavement of the slave, a machine as a slave, or on the other side of that, imply the necessity or the inevitability of enslaving humans as well. So they discuss, the researchers open up technological, cultural possibilities for imagining what human life could be with machines that are then remade as partners in that exploration. Thank you.
Thank you very much, Grant. Yeah, your ideas about AI or machine, also slave, or maybe I was wondering if you could talk about also like as a maid, for example, that could kind of open up the discussion about a machine in relation not only race, but also gender and some other issues as well. So thank you, all, Grant, Garina, and Alyssa.